national node for data and analysis. And so I want to start by just telling you a bit about NL-BioImaging. The Netherlands is quite small, but actually there are 18 different institutes involved in this project. And the real main aim of the project is to elevate bioimaging across the Netherlands. We bridge biological and technical scales, and we have various different innovative types of node, and I'll tell you more about that in a moment. But of course, to do this well, we need to think about the data and the analysis and how to integrate all of that. So we have to be fair. So this is the way we are organized into these different types of imaging modality and different approach nodes. And we have all sorts of different scientific targets that people are working towards. And as you can see, node 7 is the data management and analysis node, and we really are there to connect all the other nodes together to facilitate fair sharing. And of course, we play quite an important role in fair data management and fair image training and community building, because this is really the thing that is the integrator across all of these different activities. Node 6 is one of our innovative types of node, and that's smart microscopy. So this is about self-steering microscopes, and of course their data management is very important again, because you need very good annotation, very well organized data, very well organized ways of calling and using different analysis techniques to make this work. So how did we go about building this infrastructure? It's still in construction, if you like, because we started at the beginning of 2024. So it's only our second year, but we've made an awful lot of progress. And one of the ways that we did that was by building on components and activities that were already ongoing. Now, this is the BioImagetown Metro Map. I'm sure many of you have seen this before. It was developed by me, Josh Moore, Guillaume Guy, and Matthew Hartley during the run-up to ELMI in 2023. And we found ourselves on the same podium to talk about data management in bioimaging. And we wanted to make sure we were not all talking about the same thing, and we were just talking about all of our interesting and overlapping research in general. And this is where this map came from. It was a way of describing all of the challenges and all of the components that you would need to build a research data management infrastructure for bioimaging. And it was a way of saying which part of this puzzle, this big map, am I actually working on at the moment? So for example, Matthew is primarily involved in the bioimage archive, but to get data, high quality data into the bioimage archive, he needs to think about the experimental metadata. He needs to think about the way that the data is structured. For Josh, for example, he's primarily working with Omiro, but he needs to think about how Omiro interlinks with various different analysis tools, how Omiro works with other kinds of data storage infrastructure, such as iRods. And then for me and for Guillaume, basically for a national research infrastructure, we need to develop the whole thing, or at least make sure that our users have access to the whole thing. And so that's what we've been trying to do in the last couple of years in NL-BioImaging. And I'm going to talk to you about the data, the left-hand side of the Metro map today, mostly. So we do have a lot of tools and resources and approaches for fair image analysis, but that is the topic for another day. We have something called BioMiro, which enables a much easier integration with high performance compute infrastructure. But today I'm going to focus on the experimental metadata and the storage of data and the migration to public repositories. So this is what our national distributed infrastructure will look like, and is becoming a reality. At the moment, we have all of these different institutes involved in the project. There are 18 altogether. Everybody is generating data. They all have microscopes. So that means that we need to manage the data locally at each of these places. But of course, we need to share across institutional boundaries. We need to share between different kinds of imaging. We need to share between imaging and omics. And we don't want to be moving data around unnecessarily. So actually, a lot of the time, what we want to do is share metadata and then only share data when it becomes necessary. But of course, when it's published, it needs to go to the public repositories. And so what we are doing is instantiating Omiro databases for each of the local nodes, for each of the institutes. And that's actually means that you need some buy-in from the local institutes themselves. Some are quite willing and able and ready to do this. Others already have other activities ongoing. So there's a lot of work in the Netherlands on IRODs as a generic way of dealing with data anyway. So some nodes just have an IRODs data management system. So we have this heterogeneous ecosystem to deal with, where some people have Omiro, some people have IRODs, and some people don't have either yet, but they're in the program to have Omiro later on. So this is where we're up to at the moment. The yellow nodes are the nodes where we already have Omiro instantiated. The darker yellow nodes are where that is actually in production. The lighter yellow nodes are where that is still work ongoing. There are various places where there is IRODs instead, and they're in pale blue. So this first part is going very well. We have got a lot of buy-in, a lot of interest. People are really embracing the idea of Omiro, and we're very happy with what Omiro offers us. We now, of course, want to start thinking about the national sharing collaboration between institutes. And so for that, we're working on a national metadata node. And this is going to be hosted at an institution called SURF, which is the National Research Infrastructure institution, if you like, in the Netherlands. And they are going to be hosting a national Omiro instance and a national FAIRDM-seq instance. And the Omiro instance is for collaboration, as I just described. It's not meant as a central repository. It's meant as somewhere where you can share your data to collaborate. But once it's published, it should go to the public repositories. It's also an opportunity for the institutes who don't have local data management already to think, maybe I want the national carrier SURF to host it for me, so they can have an Omiro instantiated at SURF instead. But what we really want to do at the national node is facilitate the dissemination and integration and sharing. So this is why we have this national metadata FAIRDM-seq node, and I'll talk more about that shortly. But all of this relies on good metadata. And for bioimaging, of course, this generally these days means REMBI and instantiating REMBI for people to use. But REMBI is just general guidelines for all microscopy. So we have to instantiate that in a way that's easy for users to pick up. And to do integration across imaging and omics, then we need something to help us do that. And the standard that we're using there is the ISA standard. So if we think about REMBI, this is a picture of the REMBI guidelines taken from the REMBI paper. And you can see there are various different components to the REMBI guidelines. And for each one, there's a description of the attributes you need, and then suggestions for community vocabularies and ontologies. For our approach, what we do is we take these and we instantiate concrete templates, if you like, of these for a particular kind of subdomain of bioimaging. So we started with high content screening because we were working with the Leiden high content screening node to do this. And we made templates that would describe high content screening in a REMBI compliant fashion, but we decided very concretely which ontologies, which vocabularies to use for this particular subdomain. And so we developed things that look just like templates, where there are ontology terms that you can choose from. You can choose from drop-down lists. If you want to use these templates, they're available, and you can find them at this web address here. It's that we have published them on the FAIRDom Hub. So they're available to all, and you will find the templates, you will find examples of how those templates have been used in published data, and you'll find some extra information about how to use them. As well as instantiating REMBI, what we did was we mapped REMBI to ISA so that we could then make use of the ISA infrastructure for linking to other kinds of data. So this is the other thing that those templates provide, a way to link to the ISA standard. And the example for high content screening is called MIXME, the minimum information for high content screening microscopy experiments. It's kind of a mouthful. And we're doing this in other domains now. So we have something called MIBME, which has now been pretty much finalized, and we have something else called MISME, and it's the same kind of approach for different kinds of imaging. And this is what we can then facilitate. So this is the Investigation Studies ISA standard with different kinds of omics data and imaging data and analysis tools together. And so this is what we want to capture at the metadata sharing level at the national node as well. And this is why we're using FAIRDom-seq, because this is natively an ISA metadata structure. And I think you will be hearing more about the FAIRDom-seq later in the Data Hub presentation. So I'm not going to talk in detail about this, but this is what it provides to us. And one of the big important advantages in the near future is that FAIRDom-seq will be supporting ARO-Crate. I know there's work going on at the Bioimage Archive with ARO-Crate. There's work going on in Umiro with ARO-Crate. And this is a way of packaging data and metadata together for further integration, for migration. And I think this is the way that we see all of these different components really coming together to facilitate easier integration for the users when they want to publish, to send things to Bioimage Archive, for example. When they want to just collaborate with some new people, then it's easier to make those initial collaboration requests and sharing data in a more restricted way. So this is what we are now doing then in a nutshell. We have at the bottom of the screen, we have the local data organized either with iRods or Umiro or a combination of the two. Sometimes that can also be at SURF. And on the national level, we have the metadata sharing platform, which is a FAIRDom-seq instance. And in the middle, the very important thing to make all of this work is very well organized, structured metadata that we've tried to make concretely available to users in a very straightforward fashion. And by doing this, then we also enable easier approaches for use of image analysis, but we'll not talk about that today. Interestingly, in the Netherlands, a few other research infrastructures have also wanted to get involved with the National Metadata Sharing Initiative. So we're actually linking beyond bioimaging to other kinds of data at that level now. And so this, I think, might become a bigger way of going forward in the Netherlands with cross-domain sharing. So I see that I'm already out of time, so I will wrap up very quickly. For the next few months, we of course still have a lot of national rollout to do for the nodes that have not yet instantiated on Miro, and we're developing more efficient ways of doing that. But from a more research and development side, we have got some further work to do on this national metadata sharing node with some other research infrastructures now involved. We are developing more metadata templates for different kinds of imaging, and we are developing new methodologies for doing that in a more open and efficient way with other national infrastructures. So Katarina Strombio from BINA visited us last week, and she's doing some very interesting work in this area as well. So hopefully we're going to team up in the very near future. And of course, as I mentioned before, the metadata and data migration and packaging is a very big and important issue for the next period to come. And this all involves Aero-Crate profiles and workflows. And with that, I will just say thank you to all of the NL-BioImaging data management and analysis team, the Dutch National Microscopy Society, MVVM, the Data Management and Analysis Special Interest Group, the people at SURF that we're working with, and all of our users, and all of you for listening.